Hello, we're at the next video where we are talking about impurities. If you're new, we have a series here where I'm learning Nix and you can learn along with me. Hopefully you're doing this stuff with me, but otherwise, I don't know it yet. So unlike a lot of other videos where someone's just showing it to you and they're going really fast, I'm probably going really slow and maybe you're learning it with me. Um, Yeah, so we're using the official Nix documentation. So you can go to the website, it's in the description, and just follow along with me. If you have any questions that it wasn't clear in the video, then you can join the Discord server and just ask me directly or ask people there. And I think that's it. All right, so we're doing like these short segments, like hopefully 20 minutes. Last one was like an hour, but my brain just wasn't here. So that's pretty crazy. All right, impurities. So far, we have only covered what we call pure expressions, declaring data and transforming it with functions. All right, brain's turning on. Here's my coffee. Do you have coffee? Are you a coffee person or tea person? Pure expressions. So I guess that means it's like a function where it takes no data from the outside, so it doesn't know anything about. Yeah, it says here, in practice, describing derivations requires observing the outside world. So pure functions and pure expressions just take in data that we pass, like, numbers and stuff like that. But once you start pulling in stuff from the outside world, like the time, like file data or whatever, user input, now it becomes impure. I guess that's the idea. These pure languages like to have as much as possible pure because it's always going to give you the same response. Once you start giving in stuff from the outside world is when it's going to behave differently, right? And that's kind of what we want, but we try to want to limit that as much as possible. There is only one impurity in the Nix language that is relevant here, reading files from the file system as build inputs. Um, yeah, so obviously if we're using Nix to um, use configuration files and stuff like that, we definitely needed to read files. So it needs to do that, and those are build inputs. Build inputs are files that derivations refer to in order to describe how to derive new files. We didn't really talk like, they never explained really what derivations are, but it makes sense. It's like these are our functions or things like that, and we create new files from it. I guess that's what a package manager really does, is it like makes files and changes the file configuration files so that it runs correctly. When run, a derivation will only have access to explicitly declared build inputs. All right, so this is important because um, it makes it easier to debug since you're not going to randomly pull stuff in from the outside world. It'll all be listed somewhere so you know, like, hey, you can actually use this from the file system or whatever. And then when something goes wrong, you can say, hey, is it one of my build inputs? And check it out. The only way to specify build inputs into Nix language is explicitly with file system paths dedicated functions. All right. I guess dedicated functions are probably those built-ins or package libraries that we saw before. Nix and the Nix language refer to files by their content hash. If the file contents are not known in advance, it's unavoidable to read files during expression evaluation. All right, I'm not sure. I think I understand this sentence. It's saying that files, when you have a file, it's going to be hashed somehow, and hash functions are just going to turn it to like numbers or something like that. So it's like, hey, this file is over here. I don't want to talk too much about hashing, so if you don't know what that is, just look it up. or ask in Discord. If the file contents are not known in advance, it's unavoidable to read files. Right. So if you don't know what's in the file, you have to read it. I think that's what it's saying, and that's pretty obvious, right? Like, if you want the stuff in the file and you don't know what's in there, you have to look inside. Nix supports other types of impure expressions such as lookup paths or the constant built-in current system. Oh, that's pretty cool. Let's try that out. It was built-ins dot current, what was it called? System. There we go. Now I've doxed myself. I'm running an x86-64. Alright, so should we see what lookup paths are real quick? Where are we? Okay, we're under best practices now. You will often encounter Nix language code samples that refer to Nix packages. Alright. Well, I said last video that we're going to talk about reproducible Nix configuration, so I guess we'll look at all of this later. Alright, so we're going back here, paths. Whenever a file system path is used in string interpolation, the contents of that file are copied to a special location in the file system, the Nix store, as a side effect. Alright, so whenever a file system path is used in string interpolation, the contents of that file are copied. So whenever I use, like, if I ever create a string that has a file system path in it, it's going to actually copy that file system and move it, like a snapshot of that, into its Nix store. That's really interesting because I guess that's so that it has a copy that never changes of that file, or that maybe if I want to recreate stuff, like it can always use that file in the future, like on a new machine that may not have that file. All right. The evaluated string then contains the Nix store path assigned to that file. All right, that's really interesting. So let's do what they say here. They basically have something called a file that has just 1, 2, 3 in it called data. So let's make a data file that has 1, 2, 3 in it, and I'll write it. It's called data. You could type this into, it's just a shell thing. And then we're going to run, do a string interpolation. We had a video on this where we print out this path. So let's do it a couple of ways here. One is, let me just try printing out the path here. All right, so you see here that this is my absolute path to this directory, but we don't see the Nix store here. But as soon as I put it inside of a string and I interpolate, now we have, this makes it a string and not a path. So that's different, right? This is a path and this is a string. And it moves it into this directory or this file. So I wonder if I just like, look for that file. Yeah, so it really did put it there, and you see that the value is 1, 2, 3. Yeah. Oh, look at that. It's actually the exact same hash code, right? So it really does put the it probably looks at the contents of the file, runs a hash function on it, and then ends up with this hash code, and it puts the name of the file afterwards. So does that mean if I change this file content here and then I run the same thing again, I have a different hash file now? And then if I go back and make it back to what it used to be, Oh, look at that. Maybe I have to rerun it. Yeah, so it cached the fact that it was this value in this REPL session, but when I started again, it saw that it's now 123, and now we're back to the same hash code that we had before. That's pretty cool. So this version, when I cat this one, is going to give me the 1234 version, and then the other one is going to give me the 123. That's pretty cool. All right, they're probably going to say this now. The preceding shell command writes the characters 123 to the file data in the current directory. In the above next expression refers to this file as ./data and converts the file system path to an interpolated string. Yep, we learned all about that last time. I have bad coffee, but I still drink it. Such interpolated expressions must evaluate to something that can be represented as a character string. Right, so whenever we have something inside the interpolated, the $ braces, it needs to turn it into a character string somehow. And a file system path is such a value, and its character string representation is the corresponding next door path. I see. So basically, when we do something like, when we do string interpolation on just like a number. Oh no! String interpolation doesn't work for numbers, that's right. But we learned there was like a toString function. I don't remember where it was. But I guess like with file system path, it's automatically going to turn it to a string. But when it does that, as a side effect, it's also going to move the file or copy the file into the next door and return the value of that file path. All right. And its character string representation is the corresponding next door path, #name. That's what we noticed too. The next door is obtained by taking the hash of the file's content and combining it with the file name, what we said. The file is copied into the next door directory, next door, as a side effect of evaluation, right? So while it's trying to create its string version, it's a side effect that it does all this. It is an error if the file system path does not exist, right? So like when we did this, it worked, but if I do data 23, then it doesn't work. There's no file, no such file or directory. For directories, the same thing happens. The entire directory, including nested files and directories, is copied to the next door, and the evaluate string becomes the next door path of the directory. That is so cool. Wow, that's like a nice way to just like mass copy something, right? So let's remove data. We'll make a directory called data. And inside of data, we'll have one, and we'll make that into data 1. And we'll make 2. Oops. And we'll put that in data 2. And inside of data, we'll also make another directory called 3. And inside of 3, we'll make a file called foo. Okay, so we have under us right now, under data, we have 1, 2, and 3 as a directory. And then we have foo under 3. All right, great. So let's try this out now. Next REPL. And then we just evaluate the directory, which is data. I think, right? So now, if I go here, I have 1, 2, 3. 1 has 1, 2 has 2, 3 is a directory, and it has foo in it. That's so cool. I don't even know where I was. Okay. Right. Okay, cool. Fetchers. So this is the last subsection of impurities, or the second and last. Fetchers. Files to be used as build inputs do not have to come from the file system. The Nix language provides built-in impure functions to fetch files over the network during evaluation. We have fetch URL, fetch tarball, fetch get, fetch closure. I wonder if closure is like what, a function? These functions evaluate to a file system path in the Nix store. Example, fetch tar.gz here is going to copy it here. All right, cool. So this thing is its own hash already. So that's why when we put in the Nix store, it has the same hash, right? Oh, it's not the same hash. This part here is this part here. This is just that it's the file name, but the hash itself is different. Okay, got it. Well, I guess we might as well try that. We'll fetch a URL. I mean, there's no reason why I should type this, right? Built-ins dot fetch URL. That's our function. Oops. That's our built-ins is the constant that we learned about in the last session. Fetch URL is the function. And we're passing it a URL. It grabbed this file. And should we see what's in it? How do you unzip something? Tar. Is it? God damn it. It's X, right? Tar Z. There we go. So it has all these files inside of it. Logging sh, misc sh. Don't know what any of that is. Why depends sh. And we can look at all that, but that's what's inside of this tar file. So I wonder why we have to use fetch URL and not fetch tarball. Let's see what these things do. Fetch URL, download the thing, and then when we do fetch tarball, download the specified URL, unpack it, and return the path. Okay, so it's just basically doing one step more. It's going to actually unzip it, untar it. The Nix packages manual on fetchers lists numerous additional library functions to fetch files over the network. It is an error if the network request fails. Right, so if we do... I'm the worst typer, aren't I? If we do something where it doesn't exist, it's going to say not found, and it fails. Alright, now we're going to do derivations, so we'll stop here. Do you think it's useful to you all, like, if we looked at these fetchers list and, like, played around with them? Or, is this pretty obvious? Like, you can look at this up and, like, you can look this up and fetch CVS, wow. Old school. Talking about old school, fossil. I don't even know what fossil is. Anyway, mercurial. Those are like different version management systems. All right, great. So if this was helpful or you enjoyed the video, please like and subscribe. Join the Discord server if you have any questions or want to say hi. And next time we will do derivations. We're like so close to the end here. What do we got next? After derivations, we have some examples. And then it looks like we're actually going to be like doing configuration stuff. So we'll actually be using Nix. And then I think we're done because it says references. Get things done. Yeah, so this is what some of the stuff we looked at earlier probably. Yep, we're so close. Okay, thanks for watching. Bye.